exam, specifically tailored to the UPSC format for phase equilibrium and solutions. Section A, Phase Equilibrium. Question 1, 10 marks. A. Draw a well-labeled phase diagram of the water system. Explain why the solid-liquid coexistence line has a negative slope and state its physical significance. Answer. 1. Phase diagram of water system. The water system is a one-component, three-phase system, C equals 1. 2. Explanation of the negative slope, text, OA, line. The solid-liquid equilibrium line represents the variation of the melting point of ice with pressure. According to the Clapeyron equation, for water, melting of ice is an endothermic process, so enthalpy of fusion, delta H underscore, text, FUS, is positive, greater than 0. Anomalous behavior. Water expands upon freezing due to its open cage-like hydrogen-bonded structure. Therefore, the molar volume of ice, V underscore, text, solid, is greater than the molar volume of liquid water, V underscore, text, liquid. This makes V underscore, text, liquid, V underscore, text, solid, less than 0, negative. Consequently, frac dP, dt becomes negative. 3. Physical significance. A negative slope means that as pressure increases, the melting point of ice decreases. This explains the phenomenon of regulation and why ice skates glide smoothly. The high pressure exerted by the skate blade melts the ice underneath, creating a lubricating layer of water. Question 2, 15 marks. A. State the condensed phase rule. B. Draw the phase diagram of a simple eutectic silver lead, AgPb, system. C. Explain Pattenson's process for the desilverization of lead using this diagram. Answer. A. Condensed phase rule. In a two-component system, C equals 2, if the vapor phase is neglected by keeping the pressure constant, usually at 1, text, atm, the system loses 1 degree of freedom. The standard Gibbs phase rule, F equals C, P plus 2, is modified to the condensed phase rule. B. Phase diagram of AgPb system, point A, melting point of pure lead, 327 carat, circ, text, C. Point B, melting point of pure silver, 961 carat, circ, text, C. Curve AC. Liquidus line representing the freezing point curve of lead when silver is added. Curve BC. Liquidus line representing the freezing point curve of silver when lead is added. Point C. 303 carat, circ, text, C. 2.6%, text, Ag, the eutectic point. Here, three phases coexist in equilibrium, solid Pb, solid Ag, and liquid melt. Applying the condensed phase rule. C. Pattenson's process for desilverization of lead. Argentiferous lead obtained from ores usually contains a very low percentage of silver, e.g., less than 0.1%. Let the starting composition be represented by a point to the left of the eutectic point. The molten alloy is gradually cooled. When the temperature drops to hit the liquidus curve AC, pure lead begins to crystallize out. The solid lead is continuously skimmed off using perforated ladles. As pure lead is removed, the remaining liquid melt becomes progressively richer in silver. The composition of the liquid moves down along the curve AC toward point C. This cooling and separation process is repeated until the eutectic composition C, 2.6%, text, Ag, is reached. Beyond this point, both components solidify together, so further concentration of silver by this thermal method is not possible. Section B, Solutions and Colligative Properties. Question 3, 10 marks. Using molecular interactions, explain why a mixture of acetone and chloroform shows a negative deviation from Raoult's law, while a ethanol cyclohexane mixture exhibits a positive deviation. Answer. According to Raoult's law, for an ideal solution, the adhesive forces between different molecules, AB, are exactly equal to the cohesive forces between identical molecules, AA and BB. 1. Acetone plus chloroform, negative deviation, pure components. Acetone molecules feel weak dipole-dipole forces, chloroform molecules experience similar weak interactions. On mixing AB interactions, when mixed, the oxygen atom of the carbonyl group in acetone forms a strong intermolecular hydrogen bond with the acidic hydrogen atom of chloroform. Result. The AB attractive forces are significantly stronger than AA and BB forces. Molecules find it harder to escape into the vapor phase. Therefore, the total vapor pressure of the solution is lower than that predicted by Raoult's law, P underscore, text, total, less than P underscore A plus PB, causing delta H underscore, text, mix, less than 0 and delta 5 underscore, text, mix, less than 0. 2. Ethanol plus cyclohexane, positive deviation, pure components. Molecules of pure ethanol are heavily associated via strong networks of intermolecular hydrogen bonds. On mixing AB interactions, cyclohexane is a bulky, non-polar molecule. When added to ethanol, it forces its way between the ethanol molecules, disrupting and breaking the existing hydrogen-bonded network. Result: the new ethanol cyclohexane AB interactions are much weaker than the original ethanol AA bonds. Molecules escape into the vapor phase more easily. Thus, the total vapor pressure is higher than predicted, P_text total greater than P_A plus PB, leading to delta H_text mix greater than 0 and delta 5_text mix greater than 0. Question 4, 15 marks. Derive the relationship between the Van 't Hoff factor I and the degree of dissociation alpha for an electrolyte A_X B_Y. B. Numerical: an aqueous solution containing 1.24 text G of a calcium salt text Ca No_3 2 in 100 text G of water boils at 100.098 carat circ text C. Calculate the degree of dissociation of the salt. K_B text for water equals 0.52 text K kilogram mo carat -1 molar mass of text Ca No_3 2 equals 164 text G mo carat -1. Answer: derivation. Consider the dissociation of 1 mole of an electrolyte A_X B_Y. Let alpha be the degree of dissociation. Initial moles at equilibrium, total number of moles of particles at equilibrium. Let n equals x plus y, total number of ions produced per formula unit. By definition, the Van 't Hoff factor I is the ratio of observed moles of particles to the theoretical moles calculated assuming no dissociation. B. Numerical solution. Step 1. Find the observed elevation in boiling point, delta T_B. Step 2. Calculate the molality, m, of the solution. Step 3. Calculate the Van 't Hoff factor I. The formula for elevation of boiling point considering dissociation is: Step 4. Calculate the degree of dissociation, alpha, calcium nitrate, text Ca No_3 2 dissociates as number of ions, n equals 1 plus 2 equals 3. Using the derived formula. Conclusion: the degree of dissociation of text Ca No_3 2 in this solution is 74.65%.